go through this. Okay, the first situation is talking about 3 different basketball teams. Okay, they've played 5 games. Okay, and here's the scores. So for number 1, suppose you want to join one of the 3 basketball teams. You want to join the one that's doing the best so far. If you rank each team by their mean score, what team would you join? Good. The Jaguars, good. Because they have the highest average, and that's what the mean means. Instead of using the mean scores, you use the median scores for each team to make your decision. What team do you join? Go ahead. Careful. Coop. The Wolves. Okay. The median is the center of the data. Okay, the median is the center of the data. So the Wolves median was 80 as opposed to the Jags, which was 78, and the Lions, which was 65. So pretend you are the coach of the Lions and you are being interviewed about your team for a local newspaper. Would it be better for you to report your mean score or your median score? Mia? The mean. Okay. Because it was higher. Okay. So that's what would make the Lions look better. The mean for the Lions was 68.2 as opposed to the median, which was 65. Okay. Any questions on 1 through 3? Next page, situation B. You and your friends are comparing the number of times you have been to the movies in the past year. Here's the table, okay? By comparing the modes, which is the most frequent, which person went to the movies the least per month? Liz? Mary, good. She had a mode of 1, good. By comparing the medians, which is the center, which person went to the movies the most per month? Trick question. Yeah. Right, they all have the same. So all have the same, which was 2. Okay. Rank the friends in order of most movie scene to the least movie scene by comparing their means. Cool. Good. Sean and Brian were number 1, Kelly, and then we have Mary. Okay. Which month, by comparing the means of movies seen in each month, is the most popular movie watching month? Josh? July. Now looking at the medians, which was the least? January. Good. Okay, the last question might have stumped you a little bit, okay, the way it was asked. What is the mean of the medians for each month? So first and foremost, you have to find the median of each month, okay, which was January was 1 and 2.5, 1.5, 1.5, 1.5, 3. Hold on 1 second. Okay, so we put them in order. January, it's looking at the medians, not the average. The median of January, if they're in order, is 1. Okay, if I put June in order, it's 2, 3, 3, and then 4. The average is 3. Okay. Then what one? July? Medians. This is the medians. You look at the question. What is the mean of the medians for each month? So it is a little confusing. You have to find the medians for all 12 months, then take the average of those medians. Did anyone get that? 2.08. So once you find the medians of each month, okay, and they have to be in order, the medians, add these all up and divide by 12 to get the 2.08. Okay, yeah, yes. Okay, any questions? That's a little tricky, okay, in terms of the way it's worded. Okay, so just be careful. A lot of the questions you have seen both on homework and we'll see, a lot of these are pulled from like SATs, okay? I know. Because, yes, you know the content, but the way they specifically ask a question might be confusing, okay? So that's why this is, you're going to see a lot of different types of questions, even though we know the content, all right? So speaking of which, were there any questions on the homework, the 4.1 practice? Ash? What about it?
How do you determine I started looking at the numerical values.
Don't need it. Don't need numerical values because you're talking about categories here in terms of colors. So what is the most popular? That's the only, you can't use the mean, you can't use the median due to the fact there's no numerical values given to you. Okay, so you would use mode for that. Anybody else on 4.1? Yep. Okay, so 10. The student council surveyed students about the number of hours they spend on homework each night. The responses spanned 3 hours, so that's your range. Okay, right there, that keyword range, spanned. Falling between 0 and 3 hours, so that also proves the range. The typical response was 1.5 hours, so that's pretty much your average, okay? And the most frequent response was 1 hour, so that's your mode, okay? So it's wording. It's all comes down to wording, okay? Typical is obviously it happens more and more and more, so that's why we could pinpoint the average to it. And then the most frequent would be the mode, okay? Any other questions on these? For number 12, obviously just pay attention to the directions because I didn't at first. The median and mode it was asking for, not the median and mean. Okay. All right. So if there's no other questions, we're going to jump to 4.2, which is page 8 of your notes. All right, so this lesson has a lot of information. However, a lot of it is the same, but there's different visual representations of graphs, okay? First and foremost, what we always start with is something called our normal curve, okay? The normal curve, or a normal curve, is a smooth curve that is symmetric and bell-shaped. So an idea of a normal curve is this picture below, okay? That is a normal curve. It's bell-shaped. Some of you guys have seen that in terms of if you're looking at data for whatever reason. Also with COVID too, we've seen this as well in terms of the spread of data. For a normal curve, okay, the mean, median, and mode would approximately will be in the middle. Okay, the two sides would be symmetrical, and there are tails on either side. Okay, so a normal curve looks as is. It's bell-shaped. Your mean and median, and yes, you could say mode, but when it comes to a normal curve, we really just look at the mean, okay? But typically the mean and median for a normal curve are the same, okay? It is symmetric, so if I was to split that in half, you would get the same thing roughly on either side, okay? We call this approximately normal, okay? Approximately normal for a normal curve. We're going to see graphs a little bit later that are not normal. They look a little different. So when we look at the normal curve, there's one more measure of dispersion, which we saw for range, okay? We are using standard deviation, okay? And in our calculator, you're looking for the tool SX. That represents the standard deviation, okay? The two key words to know when you're looking at standard deviation is the variability or the spread. So if you have a large standard deviation, all your data is spread out. There's no consistency. There might be some outliers thrown in there if you have a large standard deviation, and there's no number that tells you if it's large, small, or large, okay? You kind of look at the data and you make an inference about it, okay? The technical definition for standard deviation is the average distance from the mean. Okay. Average distance from the mean. Okay. If you have a large standard deviation, that means you're further away from the mean. Smaller means you're near it. Okay. So we will be interpreting mean and standard deviation. Okay. We're going to look at different spreads of graphs. These 2 bullet points you could definitely cross out because we can't pinpoint what a good representation of standard deviation is. We can't have a benchmark, so to speak. Okay, so here are 2 graphs that represent a small spread where they're very close to the mean, or a large spread where it starts to flatten out. Okay, so think of test scores. Think of test scores. Would we want our standard deviation to be small or large? Small, right? Because we want pretty much everyone close to the average, okay? So a smaller standard deviation means there's not a lot of variability. That means all the test scores are around the average, around the mean. If we have a standard deviation of 15 in terms of test scores, that means there's no consistency. There's things all over the place, or there's extreme outliers in either direction. If we have a small standard deviation, then the majority of data is around that average, okay? So we will be creating a normal curve. I am going to give you percentages that link to it, which is called the empirical rule. Would you need to remember these percentages? No. However, it just makes sense when you're filling out this normal curve. Okay, why? What does that mean? Okay, it answers those questions. But I will not require you to memorize the empirical rule. Just I want you to see what it looks like. Okay? So when you are given a normal curve, okay, and some information like this, John scores an average of 82, okay? So when it says average, what does that represent? The mean, right? Okay? So when we are filling out a normal curve, the mean will go directly in the middle. So you have little tick marks here. It's right there in the middle where it peaks. Okay, this is your mean. Okay, then it tells you the standard deviation of 5%. Okay, so when you're looking at the first standard deviation, okay, you start from the mean. Okay, and it's the distance from the mean. So one standard deviation above the mean is you add 5 to it. So what's 82 plus 5? Okay. Okay. And then if we go above, we also have to go below. So 82 minus 5, 77. So that means one standard deviation above and below is between scores of 77% and 87%. Okay, so if I was looking at the empirical rule for John's test scores, the majority of his tests, 68% of all the tests he takes, are between 77 and 87. So if it's looking at one standard deviation, and like I'm talking about the empirical rule, it's 68% of the data falls between 77 and 87 of his test scores. It's the empirical rule, so it's set, standard, 68, 95, 99.7. I'm going to go, just let me finish so you could see where this comes from. Okay, 2 standard deviations away. Okay, so 87, we're adding 5 again. What do we get? What's 87 plus 5? 77 minus 5. Okay, so standard deviations, 2 standard deviations away is from 72 to 92. So, 95% of John's scores fall between the average of 72 and 92%. Give me 1 second. Let me finish. And 3 standard deviations away would be what? Between what 2 percentages? 67 and 97. Which is pretty much the whole curve, correct? Yes. So, this means, this is the empirical rule, 68% of John's scores will fall between 77 and 87. That's what he will receive on every test he takes, okay? 68% of his data will fall between them, okay? 95% of the tests he takes will fall between 72 and 92, okay? 99.7% of the tests he takes will fall between 67 and 97. Okay, so that's where the majority of his tests will fall. However, can John get less than 67 and more than 97? Yes, because this whole curve is equal to 100%. So, if we're only using from 67 to 97 is 99.7% of all John's test scores are going to fall between those 2 benchmarks. What are we missing? 0.3. However, less than 67, he might get 0.15%. How did I get that? 0.3 divided by 2, right? So this little tail here is 0.15% of his test scores will fall below 67, okay? 0.15% of his test scores will go above 97, yeah. They do not change, okay? They do not change. That is set for the empirical rule. So that is why, because it can be confusing, I could ask you, what is the percent of John's scores will be above 82 or higher? If this whole thing is 100%, 50%. If it's below 82, 50%, because this splits in half. Okay? How about what is the range? What is the percentage between 82 and 87? Nope. If from 77 to 87 is 68, this little piece would be what? 34. So that's how you kind of split up to find the percentages. We will not be doing that. Okay? But those 3, 68, 95, 99.7 are set percentages. They do not change no matter what the standard deviation is. They do not change. Yep. Correct. Yep. And when you are filling out a normal curve, it's only 3 standard deviations. 3 above and 3 below. It's always standard. Yeah. Correct. Yep. So like Josh asked before, if this whole curve is 100%, and this is what we left off of in black, when we subtract, we're left with 0.3. So that means these two sides have to equal 0.3. But they're symmetric, so you just split them in two. Okay? So that's where the normal curve comes into play. These are approximations, however, they're set for the empirical rule. You could find exact, but that's later on if you take a stat course. Okay? So what I want you to do is, using number 1 as an example, is just fill out the normal curve. You don't have to do percentages, just using this information given, the mean and the standard deviation, fill out this normal curve. Go ahead. Okay, when we're filling out the normal curve, what's the first number we are starting with in this? Yep, 88, which goes in the middle. Okay, what is the range for the first standard deviation? Yep. 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 Okay, how about 2 standard deviations? What's the range, Mia? And 3. Cool. Good. Okay, so when you are filling out a normal curve, this is what you should get. Okay, some of you I might ask to do extension problems in terms of using the empirical rule to answer some questions. Okay, just as a little challenge. Everyone could try it, but again, if you know how to fill this out, you are golden. Okay, the percentages come later. Yeah. Yep. Okay, so we will be finding this in our calculator. Okay. All right. We will first enter our data. Enter data in L1. Okay, we got there by stat edit. Okay, enter the data in L1. Then we would do stat calc 1var statistics, and then look for the mean and standard deviation of each. Okay, so we will be rounding to the hundredths place. Okay, for these. Now I want you to look at data set A, B, and C. Okay, which one out of those 3 would have the highest standard deviation just by looking at the data? Which has the most spread, most variability? Yeah. A. Okay, so we're saying set A would be the highest. What would come next? What would be like the middle of the road? B. Okay, because the data is a little bit closer. And data set C? The same, right? Okay, so a little recap of how we enter these guys into our calculator. Okay, go to stat, which is below the delete key. Number 1, edit, enter. If you have stuff in your L1, highlight L1, clear, then enter. Okay? In a second. So in L1, Lily's out. You're going to enter in data set A. 1, 3, 5, 17. Very short and sweet. Okay? Then below the delete key, stat, 1 over to calc, 1 var statistics. We're going to use this a lot today. Hit enter and calculate. Yep. Okay. And then X bar. X bar is your mean, so that's 8. And then your standard deviation is 7.07. Okay, SX is what you're looking for. Right? So jot that down. Now let's do number 2. Stat, edit, highlight L1, clear, enter. Then enter in 5, 6, 8, 9, 12. Okay. Stat, went over to calc, 1 var statistics, calculate. The mean is still the same, which is 8. However, the standard deviation is 2.74, which you guys were right. It's less than the first one. Okay, now do data set C. What's our mean? 8. What's our standard deviation? 0. So when we interpret data set A, we have a larger standard deviation because there's a lot of variability. Okay, if you look at the range is 16. Okay, there's a lot of variability in data set A. So anytime you are interpreting, so you guys should be jotting this down for interpret standard deviation. Anytime you're interpreting standard deviation, you should use the keywords spread or variability. Those are the two you should be using. Okay, so data set A, a lot of variability happening because you have a range of 16. Data set B, the data is closest to our mean, which is 8. Okay, data set C, there's no change. Okay, it's all the same number. Okay, so using your calculators and using what you know about mean and standard deviation, I want you to try example 1 and example 2, round to the nearest 10th. Go ahead. All right, so for example 1, what is our mean? Devin? 75. What is our standard deviation? Helena? 3.2? Are you sure? 3.5. Okay, 3.5. Good. So looking at that data, okay, average is 75, okay, and the standard deviation is 3.5. What can we say about it? Why is there a small standard deviation? Yeah. There's not a lot of spread, not a lot of variability between the speed, right? Okay. Now, if we look at Nora's science grades, what is our mean? 84, but our standard deviation is what? 15.5. Now, that has a lot of variability. Why? They're more spread out. Anything that sticks out to you? 52. Okay. We have that outlier too that's dragging it out, but it's more spread out. It's not as consistent. Okay. It's not, if the mean is 84 and the mean is dragged down because of that outlier, okay, there's a lot of variability. There's no consistency as opposed to number 1. Okay. So anytime you're looking at standard deviation, you're using those keywords, variability and spread. Okay, variability, a lot of variability, a lot of inconsistencies is when you have a high standard deviation. Small variability is when they're closest to the mean. Okay, so the first visual representation of data is a histogram. Okay, histogram uses ranges. Okay, you're in ranges, so not exact scores. Okay, and then we use frequency. Okay, in terms of how many, in this case, students scored. Okay, between a range. We then create from a histogram a frequency table. Okay, so for example, how many students scored between 41 and 50? Yellow. 3. How many students scored between 51 and 60? 5, good. How about 61 and 70 to 70? 10. 71 to 80. 81 to 90. 8. And then 91 to 100. 2. And then if we add those frequencies together, we know how many students took this. How many students? 40. Okay. There's 40 students in total that took this test. Okay. So now for C, how many students got between a 61 and 90? Careful. I hear all numbers all over the place. 30. Okay. It would be 30 because 61 to 90 is all three of those numbers. Okay. So it's 10 plus 12 plus 8, which is 30 students got between a 61 and 90. Okay. How many students got lower than a 61? 8 students. Okay. Can we tell how many students got a 76? No, why not? It's a range. We are not given specific student data. We're just giving a range. Excellent. Okay. So what typically is paired with histograms is talking about the shape of data. Okay. Talked about spread in terms of standard deviation as well as range. Okay. Now we're looking at the shape. Okay. If something is symmetric, okay, if it is symmetric, then the mean and median are pretty much equal. Okay? Labeling this as approximately normal, like a normal distribution. Okay? If the mean and median, and say if you don't have a graph and you just have a set of data, if the mean and median are roughly the same, okay, then you have a symmetric graph, okay, just by looking at it. However, if your mean and median are different, then you have a not symmetrical graph happening, okay? If it's skewed right or skewed left, pay attention to where the tail ends up. The tails are the two outer, okay? Not where the majority of data is, okay? So this first graph is skewed right. Okay, so if I was to draw a curve, the tail goes out this way, okay? If the tail is to the right, then it is skewed right, meaning the mean is greater than the median. Remember, the median is the center. The average is changing because of some extreme outliers happening. Okay? If it is skewed left, the tail is to the left, meaning the mean is less than the median. Okay? So it's very important that when you're describing the shape of the graph, you're looking at the tail, not where the majority of the data is. Does that make sense? Okay, because that will be confusing when you're given a ton of graphs in front of you. All right, so this first graph here, analyzing the histogram. Determine if the graph is skewed left, right, or symmetrical. Then determine the difference between the mean and the median. So, looking at this graph, what do you think? Skewed right, good. In terms of the mean and median, which one's greater? The mean is greater, good. Okay, so again, you are given 3 graphs below. I want you to determine which one is symmetrical, skewed left, skewed right. Once you determine that, tell me what's happening with the mean and median. Go ahead. Okay. For A, C, Lily W, what's happening? Skewed right. Excellent. Good. Good job. The mean is greater than the median. For B, Brian, what's happening? Symmetrical, so what's happening with the mean and median? They're equal. Good. Ethan, for C, what's happening? Why? Okay, in terms of the mean and median. The median is greater. So the mean is less than the median, okay, when it's skewed left, okay? And you guys will see that when we get into looking at a few different data sets, okay? Another way to represent graphs, some of you may have seen before, is called a dot plot, okay? The dot plot will look very similar to a histogram. However, you're not giving ranges. You're given specific values. So here's the example to the right. It's minutes to eat breakfast, okay? You have 0 to 12 minutes, and those dots represent people that were surveyed, how long it takes them to eat breakfast, okay? So what is the most frequent amount of time people eat breakfast? Jason? How many minutes? Most frequent? 10. 10 minutes has the most dots, most people. Okay? What is the range in times for people to eat breakfast? Yep. 0 to 12. Let's say 12 minutes. Good. How many people took 8 minutes to eat breakfast? 2. 2 people. Very simple, okay, in terms of analyzing a dot plot. But if you notice, these look very similar to the histograms we just looked at. Okay, when it's symmetric, mean and median fall in the center. Skewed right, the mean is greater than the median. Skewed left, the mean is less than. Okay, so again, looks very similar, just not the ranges. The last visual representation is a box and whisker, which is the most detailed, okay? Now, we will not be creating, meaning figuring out these numbers by hand. We will be using our calculator for it, okay? So, when it comes to the box and whisker, the data displayed is split into 4 even parts, okay? This may not be even to the eye. Like right now, looking at that box and whisker, these 4 parts do not look even, right? However, their percentages do not change, okay? So each part represents a quarter of the graph, which is 25%, okay? So there are some numbers to know of, and I'm going to use that graph to kind of pinpoint what they look like. The lower extreme, called the minimum, is the lowest value. So sometimes it's represented by a dot like that, or just left alone, or another line. The minimum is the lowest point. Something that is new to you is called the first quartile. Okay, this is what it's denoted as, quartile 1. There's 25% of the data below that. So this first line here is called quartile 1. So between the min and quartile 1, 25% of the data lies there. Doesn't matter the length, okay? Automatically 25% of the data. Doesn't change. Next, second quartile is the median, which is from quartile 1 to the median. Right here is the median, that line in the middle. That's another 25% of the data. So from the median to the min makes up 50%. Okay? Then the third quartile is another 25%. So this line right here is quartile 3. And that makes up another 25%. So from quartile 1 to quartile 3, what is our percentage? Quartile 1 to quartile 3. The box. What percent is the box? 50%. That's the middle 50% we're going to be looking at. The last number is our maximum. So from quartile 3 to the maximum is 25% of the data, no matter what the length is. Okay? One piece of information that we look at to describe the middle 50% is called the interquartile range. Okay? The interquartile range is quartile 3 minus quartile 1, which gives you the middle 50% of data. Okay? Now, if we think back of the measures of central tendency, mean, median, and mode, okay? If there was an outlier, which one would we use? Mean, median, or mode? Median, right? So if there is an outlier with the data set, we would use the median and the interquartile range to describe the spread. Okay? Interquartile range is looking at the middle 50% of the spread of data. Okay? So if there are outliers, you would use the median and interquartile range. If it's pretty much normal, okay, the mean and standard deviation would be used. Okay? So we're going to look at this thing in our calculator. Okay? This is called min, first quartile, second quartile, which is the median, third quartile, and the max is called your 5-number summary, which we actually saw this already in our calculator when we were looking at the median. Okay? The 5-number summary is your min, lower extreme, which is quartile 1, median, quartile 3 is their upper quartile, and the max. So we're going to try number 3 in our calculators. Stat, edit, enter. If you have anything in here, highlight L1, clear, then enter. Okay, and we're going to enter the data. So 320. Okay. Once the data is entered, we're still going to the same screen. Stat, one over to calc, one var statistics, enter, calculate. Okay, pay attention. The mean is 370. Okay, just keep that in the back of your mind. But if you scroll down, here's the 5-number summary. The minimum, so you're going to jot this down, 270. Quartile 1 is 315. The median, 340. Quartile 3 is 430 and 580. It's all there. All there. Okay. The minimum, 270. 315, which is quartile 1. 340. 430 is quartile 3, and the max is 580. Okay, so that is your 5-number summary, which is given to you. Okay, now when you are graphing these box and whiskers, okay, box plots, the graph goes above the number line or below, not on it. Okay, so you guys can come up with the scale as long as it's consistent. Okay, mine might look different than what Lily chooses or what James chooses for your scale as long as it's consistent. I have seen people just write those 5 numbers on your scale. That's incorrect. That's not how we graph. Okay, so on your scale, I started with just looking at my range, 270 to 580. I would go up by 50s, but again, you could choose whatever you want. Okay, I went up by 50s, but again, you could choose whatever you want to. All right, the minimum is 270. I'm going to put a little dot for the minimum. Quartile 1 is 315. Put a little line for quartile 1. 340 is the median. 430 is the upper quartile. And 580 is the max. And again, I am just going through my scale. Okay. Here's what your box plot looks like. Yours might look a little bit different than mine, but it's okay. You get the general idea. Looking at our box plot, anytime you have to determine, God bless you, if it's skewed or not, or normal, whatever it is, you always go from the median. Okay? So looking at this, would this graph be symmetrical, skewed left, or skewed right? What's our first instinct? Left? Skewed left. Be careful of the meaning of it. You're looking where? Yeah. Skewed right. Going from the median, right? Just looking at it where the longer tail ends up. Okay? And I'm going to explain that in a minute. So you guys think skewed right. So what does it mean if something is skewed right in terms of mean and median? Good. Okay, so if it's skewed right, the mean is greater than the median. If we look at our data that was entered, remember our median is 340. If I scroll up, my mean was 370. So that proves that this was skewed right. Does that make sense? Sometimes the scale might be completely off, or you might think one way and it's the other. Go back to your data and look at the difference between your median and mean. Does that make sense? And that's how to check it and confirm your thought. Okay? So you guys are going to try the next example, which is example 4. Okay? Find your 5-number summary, graph it, and then we'll go from there. Okay. For your 5-number summary, you should have gotten the minimum of 63, right? Quartile 1 is 71. Median is 74. Quartile 3 is 79. And the max is 84. How many of you did get that? Good. Okay. Now, looking at your graphs, what would you say? Yeah? Symmetrical. Do we confirm it with our mean and median? We have a median of 74, and our mean is 74. So that's a symmetric graph. Does it really look it when you look at your graph, though? Kinda, right? But that could be skewed a little bit, right? So you always want to look at where the median is and look at the left and right. Okay? Does that make sense? All right. So now the main idea why we do these is how to interpret. Okay? So if you look at the next page, and we're going to try some on our own after this. Some of these are not drawn to scale or it's hard to see. So that's why you're going to see the word approximate all the time. All right. So what is the approximate median of Angela's sales? Okay, so if you have to, where does the median fall? Which one? Where would it be? Is it this? Here? This one, right? So here's the median. If I draw a line down, what can we approximate? 27, 26, 28, around that ballpark. And again, it's an approximation. So the median of Angela's sales, anytime we say approximation, we use that. And we'll say 27, okay? What is the approximate maximum number of Carl's sales? If you have to draw lines to see, you can. Maximum number, 62. Remember, the maximum is your last spot here, okay? So now, which salesperson has a smaller median? Angela, good, okay. Now we have some true or false. 25% of Carl's sales were between approximately 15,000 and 32,000. Liv? True, because where does 15,000 fall? The first quartile. So here's 15,000 as the first quartile. And where's 32? The median, right? So from quartile 1 to the median, remember, is 25%. So this is true. Okay? It's approximation. So here's where 15,000 is. It's an approximation. It's between 10 and 20.
Oh, so those numbers on the bottom represent thousands.
Yep. Okay. Right here. Okay, no problem. And then 32,000 is here. So true or false, 75% of Angela's sales were between approximately 18,000 and 58,000. Jason? You are correct. True. Okay, because where does 18,000 fall? First quartile. So the median we know is roughly 27, right? This one is 45, and then we have 58. So from quartile 1 to the max is your 75%. Okay? All right. So we're going to do some practice in terms of interpreting. Okay? You may work together through this. However, before we start, I'm going to give you the numbers because they're kind of hard to see. The 5-number summary. Okay? So for this first one, the minimum is 38. Quartile 1 is 72. The median is 88. Quartile 3 is 96. And the max is 1 and 2 for this one. Okay, turn the page, 6 through 9. Average minutes per night spent on homework. 0 is the minimum. Quartile 1 is 20. The median is 48. Quartile 3 is 60. And the max is 190. Okay, so I want you to work 1 through 9. Okay, we will be going through these before the end of class, so you have about 8 minutes or so. I think we'll all finish before that. So 1 through 9, we'll go through it together. You may work on it. Okay, and again, what did I say regarding your test? Okay, what is the highest score on the test? Number 1 is 102. So that was correct. For number 2, what is the percent of the class scored above a 72? Is 75%. That is also correct. What is the percent of the class that scored between 88 and 96, which is the median to quartile 3, which is 25%. Do you think this test is too hard? Coop, why not? Okay. Okay, what else can we say? Yep. What percentage? 75%, this wasn't too hard because 75% earned a 72 or better, and 50% earned an 88 or better. Okay, so this test was not too hard. And then what do you expect the mean to be above or below? And then explain. Below is correct. Why? Yep. It's skewed left, and you also have that outlier of 38. Okay, good job, you guys, whoever put those on the board. Nice job. All right, 6 through 9. What percent of sophomores spend more than 60 minutes on homework per night? 25% is correct. What is the range of times that the middle 50%? Coop? 20 to 60 or the 40 minutes? Okay, either one's acceptable. What percent of sophomores spend less than 20 minutes a night on homework? 25% is correct, which is on the board. Okay, what do you expect the mean number of minutes to be, higher or lower? Jason? Excellent. It's skewed right because it has an outlier of 190. Nice job. So, knowing this information, you have to know how to interpret, okay?